Okay, let's see what we got here. And it's gonna be medium. Another binary, yeah, yesterday was binary trees as well. All right, given the root of a binary search tree, return a balanced binary search tree with the same node values. If there is more than one answer, return any of them. Turn a balance, oh, I see. So they want us to kind of modify the tree. Binary search tree is balanced if the depth of two subtrees of every node never differs by one. The depth, right. So 1, 2, 3, 4 becomes 1, 2, 3, 4, where the 2 is the root. Or it could be 1, okay. 1, 2, 3, that's already balanced, so you just return the same root. Okay, so they want us, basically it's going to be a modification of the original root tree, or the original binary search tree, but balanced. I guess balance is not necessarily always assumed or always there for the first tree. So binary search tree does mean that there's going to be at most 2 children nodes for every node. What's the simplest way of doing this? Connection is actually not, oh, the connection is actually not, you can just build the tree any way you want, I see. So it doesn't have to be the same connection. So like normally, I guess you have to change the connections because if it's like this, there's just no way you could actually form it if it's the same connections. Okay. This is medium. The same node values. Okay. This is not the only correct answer, right? The same node. So, I mean, I guess that just means you just pull the values from the tree itself and then create a new tree that's balanced using it. Okay, that's pretty easy actually. Well, I guess anything with binary, actually, I mean, yesterday I had binary tree and it wasn't easy, but this is kind of the same difficulty, I want to say. Okay, anyways, let's say the values is an array, kind of a global array. And then I'm going to just go ahead and recurse to add node values to node values to array. Okay, so I'll do I guess there's gonna be 2 recursive functions, one to go down and to get the values. So I should probably just do like find values. The node is the parameter here. But I don't think there needs to be a return. And it'll just basically do something simple like if it's a node, then it could be null. If it's node, then values.append node.value, node.val, and then recurse to the left side, recurse to the right side, and then that's it. So at that point the values should always be here. And then I guess it should be something like, I guess I just do a stack. So on the second go around where I'm trying to create the tree, I want to do a depth first search so that actually will a depth first search so that it won't actually create some. No, breadth first search, so that it'll actually kind of fill in the rows, fill in the nodes each depth. Breadth first search. So recurse to create the binary or balanced binary tree. This should be breadth first search. Alright, so what's the recursion for breadth first search? So I need to do a node, do its children before doing its children's children. Do the children before doing its children's children. I think, right? Depth first search is generally the most straightforward way of recursing. I did go over this, right? Breadth first search with recursion. So do you do the children's first? Do you do the children's first? So if the values of the nodes are 1 through, let's say, 8, ideally you do 1, there's 2, 3, 4, 5, 6, 7. And then somehow 8 gets down here. I mean, you could do something where you have a maximum depth. You could pre-calculate what the maximum depth it should be and never go above it. Never try to exceed it. At that point, you kind of do a depth first search. Does that work? Would that work? Guess not. Because in theory, it could still be something like, I don't know, something like this, and that wouldn't be balanced. You create the node, create the parent node, and then you recurse to this side. You recurse to that side. And then when you create this one, I mean, you could do something where you cap how many nodes there are. When you recurse, you specify which values of nodes to use. So if you do this one and you recurse to the 2 and you say that the 2 should only do 5 values. Yeah, maybe that might work. So when you recurse, you say how many values should be on that branch. Okay. This doesn't seem like something I saw before, but who knows? Was it necessity or some other random inventions? Okay, so I'll say create. and then it'll pass a node. And I guess it needs to be a tree node. Okay. And it needs to pass the number of values that it should, or the kind of the total number of nodes you should use. I guess I'll just use count. So then the first time it'll do something like, I guess I can maybe do the trivial case. If count equals 0, then just return. Otherwise, it should do something like node dot value equals values dot pop. Take a value from the stack, and then I say count minus equals 1, and then I do node dot. I say create node. I need to create an actual tree node. I guess if I create an actual tree node, then maybe I shouldn't use count, because I really don't want to create an empty tree node. So here, if I guess the left count is going to be this thing divided by 2. This be rounded down. I guess I'll do the right count be rounded up version. I think that still adds up to count. Count plus 1 divided by 2. And so if like count was 3, then left count would be 1 and right count would be 2. I guess because I do the count minus equals, maybe I don't need to do this. If I just divide, no, I need to do that. I guess maybe, so instead of subtracting here, I do division. I guess this might be count minus 1. Yeah, just count minus 1 divided by 2, and count divided by 2. I guess this could be also just count and count minus 1. Yeah, count. So this is going to be, left side is going to be slightly higher maybe. So if count was originally 4, then left count will be 2, and then right count will be 1. Or if right count was originally 5, then the node itself is 1, and then 2 on the left, 2 on the right. Okay. And then I do something like if maybe I should do the if statement here. Oh, whatever. If left count, if there is a left count, then node dot left is equal to tree node. I think it's tree node passing in. All those things are optional. Okay. All parameters are optional value left and right. And then I can do something like create node.left if right count, then node.right equals tree node, create node.right, and then I don't need to I need to pass the second parameter, left count, right count. And then I think I can just say create Do need to create the root node. So uh, balance root is going to be the tree node. Yeah, just an empty tree node. Create based on the balance root and the number of values and values, so the length of values, and then return the balance root. Okay, I think this should work. Unmatched parentheses. Pop for an empty list. Interesting. Values.pop. Okay, let's go ahead and see what's going on. So I should print out like 4 values. Okay, values doesn't work. Excellent. Oh, I didn't call find values. I'm a dum-dum. Find values on my root. And access free variable values where it's not associated with it in the closing scope. Okay. Not my greatest coding. Interesting. Oh, I do need to actually have null. Okay. I do need to have nulls. Else node.left equals none. I mean, isn't that null? I guess that. I don't know. So it's not actually. Oh, actually, I guess no, I'm looking at the wrong thing. No, I'm looking at the right thing. 4312. Wonder. Okay, let's go ahead and just look at this thing right here. Just building the tree wrong somehow. Do I need to actually do node.left equals tree node? I wonder if that makes a difference. That doesn't seem right. I mean, I don't think null is an actual, you know. What am I doing wrong? What am I doing wrong? I mean, I can make a tree node and just have it not initialized to anything. I don't think this is correct. Yeah, it's just zeros. Hmm. I mean, I think so what is it currently doing? It's giving 4312. Why is this 1, 2, 3, 4, 5, 6, 7? And this is 9. How did it get 9? Alright, let's go ahead and just take a deeper dive here. I think maybe this is correct. 4, 2, 1. So that means on the node 4, it should have 2 on the left and 1 on the right. On the node 3, it should have 1 on the left, 0 on the right. Oh, this is wrong. 3 should have 0 on both sides. When you pass in 3, it's 2. 2 divided by 2 is 1. No, is that right? No. No, I guess that's right. Yeah. So it'd be 4 and then 3, 2, where the 3 has 1, so it should have like 1 here. It should be something like 4, 3, 2, and a 1 on this side. Although that's really not what's doing. 4, 3, 1, 2. Guess I'm just not returning the array correctly. What does this mean? The root is 1, null on the left, 2 on the right. And then the 1, the 2 has null on the left, 3 on the right. The 4 has null on the left. I don't know how to parse this actually. Maybe it doesn't seem like it's like, doesn't seem like something I'm used to seeing. Just not building the tree correctly. Node.left equals tree node. And then that huh. Man, that's really high acceptance rate. Oh boy. Node.left equals tree node. Create node.left. There's some number on the left, some number on the right. If the left count with the left count, there is left count, create it. There isn't, then do what? What does null mean? How can I output null in my thing? It's not like node.left is none. Right? And I don't think I can do that. I don't think that does anything. No dot left equals none. No dot right equals none. I think I tried this. Do. Yeah, that just makes zeros. Although I'm not sure why it made so many. Well, did I run it? Do 213 null 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 4. Optional tree node. I don't. What am I doing wrong? Balanced. Node dot left. It creates the node originally. The node. I mean, when it creates it, the left and right are none already. So why do I need to do this? It's just redundant. Although, yeah, it's just redundant. Guess I'm not sure why. I'm not sure why it doesn't work. When values balance root, create the balance root. Create the tree node. The tree node. Move to that tree node. Oh. Hmm. Okay. I'm gonna